Welcome to episode 3 of the Area Podcast. Today we're going to talk about how the distributive property of multiplication can be used to help find area of figures that might have bigger lengths and widths. Let's hop right in. Remember, multiplication and area go hand in hand because we arrange the square units inside of squares and rectangles to measure area just like you would an array. The distributive property of multiplication is a property that allows for a figure to be broken into two smaller pieces, solved, then added back together to find the total of the figure as a whole. In area, that will help us break apart larger figures and find the area in a simpler way. I have a rectangle with a length of 9 and a width of 6. That's really big, so I'm going to use the distributive property to break it into two smaller chunks before adding them back together. I choose a place in the figure where I'd like to draw a line. I'll make a vertical line to break my figure into two smaller pieces. Stop for a second and consider these questions. Did I add any square centimeters into the shape or take away any square centimeters? The answer to both of these questions is no. Now when I look at the figure, I see two smaller rectangles. This will allow me to find the length and width of each and make calculations easier. I label each smaller rectangle with a letter A or B so that I know the difference between them. Let's find the area of these smaller rectangles. Rectangle A's length is 4 centimeters and width is 6 centimeters. I use my equation length times width and multiply to find the area. 4 times 6 equals 24, which means the area of rectangle A is 24 square centimeters. Rectangle B has a length of 5 centimeters and has a width of 6 centimeters. I use my equation length times width, multiply 5 times 6, and get 30. So the area of rectangle B is 30 square centimeters. The second part of using distributive property is putting the original figure back together. To do this, I have to add the two areas of the smaller rectangles back together. Rectangle A had an area of 24 square centimeters. Rectangle B had an area of 30 square centimeters. 24 plus 30 equals 54. So the large figure we began with, 6 by 9, has a total area of 54 square centimeters. That also means 6 times 9 equals 54 square centimeters. Now it's your turn to try. Here is a large figure. You must find its area using the distributive property. In your notebook, show your work. You can redraw the figure or use objects and record your work. Please explain the process you went through to find the area. Your notebook will be checked in the morning for your work. Decide where you would like to draw your line, then begin your math. Pause the podcast here to do your work. Our episode has come to a close. To close out your work for episode 3, please visit your Kahoot challenge on our website. See you next time.